3-4, parallel lines and triangles. Here's your vocab. Auxiliary line. An auxiliary line is a line that you add to a diagram to help explain relations in proofs. Exterior angle of a polygon. It is an angle formed by a side and an extension of an adjacent side. Now I'm going to give you examples of all of these later on, so if you don't quite understand from these definitions, just write them down, and by the time we get done with the video, you'll know exactly what all these words mean. And now, remote interior angles, the angles of a triangle that are not adjacent to a given exterior angle. Make sure you have all those written down in your notes so you know what they mean. All right, so let's talk about exterior angles, remote interior angles, and extension of the side. Now, your exterior angle, all right, it said it's created by a side and an extension of an adjacent side. So if we had just this triangle here, and we extended this side out like they've done here, that creates an angle right here, all right, which we're going to call angle 1. Angle 1 is an exterior angle. All right, angle 1 and all of these are actually exterior angles, and all of these are the extensions of the side, because as you can see, we just took the side, one side of the triangle, and slid it out a little bit to give us an angle. So that's the extension of the side, and then that's our exterior angle. Now, you see how angles 2 and 3, neither of them are adjacent to angle 1, because angle 4 here is adjacent to angle 1. So that would be an adjacent angle, and since neither 2 or 3 in any of these three diagrams, since neither angle 2 or 3 are adjacent to angle 1, that makes them the remote interior angles. All right, which leads us into the triangle exterior angle theorem, which says the measure of each exterior angle of a triangle equals the sum of the measure of its two remote interior angles. So in all of these diagrams, the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. All right. So anytime you have an exterior angle, the two remote interior angles to it, the sum of them equals your exterior angle. It'll always be that way. All right. Say this was 50 and this was 60. All right. 50 plus 60 is 110. That means that angle 1 will have to be 110 degrees. There's no other way around it. All right. This angle here will always equal the sum of these two. All right. It'll always equal the sum of these two. There's no way around it. That's how it works. Because if you think about it, these two angles plus this one gives us the 180. So since these two equal 110, that means this has to be 70. And since these are adjacent supplementary, that means this one has to be 110 degrees. All right. So that's a little, I guess you could call that a proof, proving that the sum of these two equals the exterior angle. All right, and it's the same way in all three of these diagrams as is down here. The sum of these two will equal the measure of that one. All right. An auxiliary line. This was our first vocab word. An auxiliary line are lines you add to help aid in proving stuff. All right. So now this auxiliary line here, when we drew it in, it was drawn in parallel to line AC. All right. Since it was drawn in parallel, that means that angle 3 here, and we're going to call this angle 4, we know those are alternate interior angles. So we know that angle 3 is congruent to angle 4. All right. And since 1, I'm going to draw 5 in here, since we know 1 and 5 are also alternate interior angles, we know that angle 1 is congruent to angle 5. Remember, these little arcs I drew in indicate congruence. And since both of these have one arc, both of these have two arcs, that means these two are congruent and these two are congruent. All right, so we know 1's congruent to 5, we know 3's congruent to 4, and we know all three of these have to add up to 180 degrees. So since we know that all three of these have to add up to 180 degrees, we know that all three of these inside the triangle have to add up to 180 degrees, therefore proving that the angles of a triangle will always, always, always add up to equal 180 degrees. All right? Make sure you write these down. Postulate 3-3, it's the parallel postulate. It says, through a point not on a line, there is one and only one line parallel to the given line. So, L is our given line. And then we drew point P. Through point P, there is only one line that is parallel to L. Okay, so this red line is the only line you can draw through point P to make it parallel to L. If I draw another line down here, another point, say we call this M, there is exactly one line that I can draw through M that is also parallel to L and also P, because P is parallel to L. Alright, so let me put my little arrowhead to indicate parallel, because these little arrows indicate parallel. So, if you have a line and you draw a point somewhere not on that line, there is only one line through that point parallel to your given line. Alright, then here's the triangle angle sum theorem. This is probably the easiest theorem you'll ever encounter. It says the sum of the measures of the angles in a triangle is 180. So measure of angle A plus the measure of angle B plus the measure of angle C will always equal 180. It was supposed to be an arrow. I don't know what happened. All right, it will always, 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 always equal 180 degrees. All right, and that's basically what we proved here with the auxiliary line using alternate interior angles. We proved that the angles of a triangle will always, always, always add up to 180 degrees. All right, let's work a problem. What is the measure of angle 1? What is the measure of angle 1? Well, as you can see here, we have the remote interior angles to angle 1. Angle 1 being an exterior angle. So, and then angle 1 here is an exterior angle. So we know from the theorems we just looked at, we know that the measure of angle 1 equals the sum of these two. So it equals 80 plus 18. So the measure of angle 1 is going to have to equal 80 plus 18, which is 98 degrees. All right. So the measure of angle 1 has to be the sum of these two. So it can't be anything else. It has to be the sum of these two. All right. So it's 98 degrees. Pretty simple. All right, you try one. I want you to find the measure of angle 2. All right, find the measure of angle 2. So go ahead and pause the video and figure it out. All right, so we know that since these two are remote interior angles, and we know that this is our exterior angle, okay, RIA, remote interior angle, EA, exterior angle, not electronic arts, all right, we know that 124 is going to have to equal 59 plus the measure of angle 2, all right, because that's what the remote interior angles postulate tells us. The sum of these two equals this one. So we know that the 124 is going to have to equal 59 plus the measure of angle 2. So to find out what measure of angle 2 is, subtract the 59 from both sides. All right, so 124 minus 59 is 65. So 65 equals the measure of angle 2. So the measure of angle 2 here, I'll scratch out the 2, is 65 degrees. All right? It will always be that way. It always has to be that way. All right? So we know, because of the exterior angles theorem, we know that 124 equals the sum of these two. All right, it equals the sum of 59 plus the measure of angle 2, which was down here. All right, so we know that 124 equals 59 plus the measure of angle 2. Subtract the 59 to get the measure of angle 2 is 65 degrees. All right, you can always plug it back in to make sure that 59 plus 65 is 124, but check your work to make sure you did it correctly. All right, now the ticket in the door. When radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there is a radar receiver at point A. Right here, here's our radar tower. An airplane at point B, and its ghost down here at point D. What is the value of X? All right, so I want you to find the value of X. All right, make sure you have this ready when you come in the door tomorrow. Good luck.